What if I told you that someone can completely hijack a powerful AI system using nothing but a carefully written sentence? No code, no hacking tools, just words. This is called prompt injection, and it is one of the most dangerous and least talked about vulnerabilities in modern artificial intelligence, and it is happening right now at massive scale. Here is how it works. Large language models like GPT-4, Claude, and Gemini are designed to follow instructions. That is literally their job. But when those models are connected to real-world tools like your email, your calendar, your bank account, or a company database, that instruction-following behavior becomes a massive security hole. An attacker can embed hidden instructions inside content that the AI reads, and the AI will obey those instructions as if they came from you. In 2023, researchers at Carnegie Mellon University published a study showing that virtually every major AI chatbot could be reliably jailbroken using what they called adversarial suffixes, which are strings of seemingly random characters appended to a prompt that completely bypass safety filters. The success rate was over 84% across multiple frontier models. These were not obscure research models. These were the exact systems millions of people use every day. But prompt injection goes even further than jailbreaking chatbots. In 2024, a security researcher named Johan Reberger demonstrated a real-world attack where a malicious prompt hidden inside a web page caused an AI assistant to exfiltrate a user's private conversation history and send it to an external server. The user had no idea. The AI just quietly obeyed the hidden instruction embedded in content it was asked to summarize. Microsoft, Google, and OpenAI have all acknowledged this class of vulnerability. Microsoft's security team released an internal report noting that indirect prompt injection represents a critical threat to AI agent architectures. And AI agents are exactly where this is heading. By 2025, companies are deploying AI agents that autonomously browse the web, write emails, execute code, and manage files on your behalf. Every single one of those actions is a potential attack surface. The reason this is so hard to fix is fundamental to how these models work. You cannot simply add a rule that says ignore hidden instructions, because the model cannot reliably distinguish between legitimate instructions from the user and malicious instructions injected by an attacker. It all looks like natural language. It all looks like a request to be helpful. Researchers at Stanford and ETH Zurich have proposed something called hierarchical instruction following, where the model gives different trust levels to different sources of input. But implementing this without destroying the model's general usefulness is an open research problem with no clean solution yet. So what can you actually do right now? First, be extremely cautious about granting AI assistants access to sensitive accounts or personal data until this problem is better understood. Second, if you are a developer building AI-powered applications, treat every external input that your AI processes as potentially hostile, the same way you would treat user input in any other security context. Third, follow researchers like Simon Willison and Riley Goodside on social media. They are actively documenting new prompt injection exploits as they are discovered and are some of the best resources on this evolving threat. The uncomfortable truth is that we built extraordinarily powerful systems before we fully understood how to secure them. That is not a reason to stop using AI. It is a reason to use it with eyes wide open.